Hi everybody. Well, I had a little bit of time this evening and I went through some of the comments from the last video, and there was a lot of good advice and a lot of good comments, and I wanted to address a few of the questions that I received as well. So I thought I would, first of all, let's go back. I had a lot of questions regarding things related to, like, can you inject a signal into the preamp and everything after, like where the head feeds into on the tape deck there, and see how it reacts. Well, I actually did that, and I filmed it, I recorded it, but it didn't make that video. So what I might do is I may put that in this video as one experiment. We're going to do a few experiments in this video. I don't think we're going to actually repair anything in this one, but rather we're going to find some things out just by doing some experiments. And I will put that video in there. Now understand, it can be a little bit misleading. What I did was, at the front end of the preamp, right after the JFET stage where the head feeds into the input JFET, right in there I injected a signal. And I showed you where it's actually boosting the lower frequencies and it's attenuating the higher frequencies. And I used 5 kilohertz as a knee point where I did that. Now, I used that because the only information I was able to find online was this old patent. And this is for, one of you even brought this up, this shows for old style tape, and I don't know if you can see it on there, but the two tape types are 19 centimeters per second and 9.5 centimeters per second. And I believe cassette tape runs slower than that, and that does affect this EQ curve. But this is actually the equalization curve for playback and recording on tape. So theoretically, you could start at any point, and if I go lower in frequency, it'll kind of boost it, you know, the amplitude will go up, and if I go higher in frequency, the amplitude will go down. So really, don't get confused by what I used as the center point of 5 kilohertz. If you look on this cross point here where the recording and playing intersect is, if you go down, it's right at 5 kilohertz. And like I said, on other tape speeds and other tape formulas, like, you know, metal and chrome and so forth, those numbers are different. Okay, so really all we wanted to see by doing this experiment is, does the equalization circuit affect the signal? So if I put a signal of the same amplitude in, will I get the same amplitude out, or will I get a different amplitude based upon the frequency? So I basically put 5 kilohertz in there, measured the output, and that would be X. That's our reference. And then I didn't change the amplitude of the signal or anything like that. I just changed the frequency and going up and down to see how it tracks. So we'll do that. Now, one thing I failed to do in that experiment, and that was to adjust the equalization adjustment to see how it affects that. In retrospect, I should have done that, and we may do that in a later experiment here. But that answers that question. Another question that I got, or another comment, was the importance, because we're still questioning whether this tape head is bad or not. Another question I had was I using a new enough tape? Well, let's go through the list of tapes. For Wow and Flutter, I have this tape right here. I have not used it other than for this, but I did purchase it several years ago. And if you look at the date on it and everything, this was manufactured December 26th of 2018. So there you go. And it has almost no use on it other than what you saw me using it. I have one of these older tapes from way back. This one was made in 1981. it has a series of frequencies on it as well. And there is a possibility that the high frequencies may have degraded a little bit. Cassettes do degrade with time. Number one, how many times you play them, and number two, just sitting around, they can lose the high frequencies a little bit. It's debatable. I've seen old tapes that were very old and still performed extraordinarily well. So I'm not totally convinced that just because a test tape is old, it is no longer good enough to use. Although I do know that it can degrade. I just don't think it always does. I don't think it's a constant. More importantly, I splurged and I purchased 2 tapes from Gen Labs. Any of you that work on cassettes know this company and their reputation. These were ordered, I will admit, full disclosure, I ordered this one and I ordered one other one, and they are specifically made to the specifications of the Pioneer test cassettes from the day. They are fresh recordings. They are only about a month old, and they are expensive. You will drop a lot of money on one of those relative to what it is. It's a cassette with some noise on it, really, with some tones. But they're very accurate, and honestly, you can do certain things on these cassettes without a test tape, but you are limited. The only way to know that it's aligned properly and that all of the equalization and everything is set properly, if you're going to play with that sort of thing, is to have a proper test tape. You have to have it. It's a must. And they have to be traceable. In other words, it has to be done by a reputable company in a traceable manner so that you know that those recordings are correct. And you can't just throw them around, and you got to make sure the heads are demagnetized and everything before you put them in, or you're going to waste your investment, because it will damage the tapes, especially at the high frequencies. So I'm aware of all of that. I've been taking the proper precautions. So I don't think it's anything to do with the test tapes that I'm using. Last of all, I did a wow and flutter test with those new pinch rollers that I purchased from, I guess they're made in China, I don't really know. They were cheap. They were 4 for $23, including the brass hubs. It was the entire assemblies. The wow and flutter turned out to be about 0.08, and I had it in my head that that's what it was supposed to be. Somebody called it out on one of the comments that it's supposed to be 0.03, and sure enough, I went back, I looked in the service manual, he was correct. So thank you for the correction. It is 0.03% wow and flutter, JIS standard, weighted average, and that's what I was testing it at. So it's definitely too high. And I went back and looked at the video. I said that it was 0.8, but the indicator was pointing more to about 0.6 to 0.7. Not a big deal, but it's still double what it should be. So we're going to have to revisit the wow and flutter, and I think it has to do with those pinch rollers. I'm sure there's some things we can do to improve it a little more, but I have a feeling to get it to be perfect, we're going to have a proper set of pinch rollers, and we'll just have to wait till Terry at Terry's Rubber Rollers is back up and running and able to rebuild the ones that I have. So that takes care of that. So I just wanted to give you that little, just answer a few of the questions and comments. You gave me a lot of good suggestions to try, like reversing the 2 input leads from the right and left channel of the tape head to see if the problem follows the head, and a few things like that. One of you gave an exemplary description of how the equalization circuit works with the 6 dB per octave, and how that little filter network with the capacitors and the resistor, it's a very simple filter network, and we saw that when I showed the schematics on the last video, and how simple it is compared to the complexity of an RIAA phono equalization circuit. So again, this should be easier to deal with than phonograph, believe it or not. And really, when you look at the circuit, it's the truth. It's not that big of a deal. So simple circuits, have simple problems. So there's not a whole lot it can be. And this is where we left the last videos. There's not a whole lot it could be, right? So let's do some experiments and take some measurements on this just to see how this circuit works, to get a better understanding of it. And then maybe by the end of this video we can make a better determination whether we need to replace a tape head or whether we need to replace what's in this head, which is really pretty possible, huh? So if that sounds interesting to you, stay tuned, and that's what we'll be doing. Okay, time for the ramblings of the village idiot. I really shouldn't be doing this because I haven't done this stuff in a long time, but I thought it would be a fun exercise for me to do, and either for you all to learn something or for those of you who really know what you're doing to have a good laugh on me. So looking at this, the tape head is connected over here. So moving the camera real quick. So you can see the head going into this section. I just kind of have it cropped off because I expanded the picture a little bit. Alright. And so here's the head coming in. The signal goes through this JFET, gets coupled through this cap, goes to this 2 stages of amplification, and then you can see at the output of here we have negative feedback loop going into here. So a lot of you that work on amplifiers are familiar with negative feedbacks, and that's what this is. The difference is this little circuit here, and of course you put 2 capacitors in parallel, they add up. So if you have a 0.022 or a 22 nanofarad and a 2.2 nanofarad cap and you put them in parallel, you have 0.0242 microfarads or 24.2 nanofarads, however you want to say it. So this is going to act as a filter, a high-pass filter. And what it's going to do is, as the frequency here increases, the resistance, or the reactance I should say, of this circuit will decrease. And you can calculate a filter like this with this little formula. So you take the impedance of the resistor and the capacitor, and correct me if I'm wrong on this, is the square root of 1 over R squared plus 2 pi FC, which is your capacitive reactance formula, squared. So if you take all that and then you plug those numbers in, and if I used an online calculator, I'm not going to sit here and type all the numbers in. Using an online calculator, you come out with these numbers. So at 20 hertz, you can see this is really high impedance. It's 120.895 K, so it's 121,000 ohms almost. And when you get up to 20 kilohertz, you're down to about 328 ohms. So you can see the big difference. So this is really beginning to massively influence that circuit. Okay? And these 2 resistors are in there in order to attenuate the amount of feedback that you're allowing. So by putting more or less resistance on this variable pot, we're allowing more or less of the signal to pass through this filter and go in here. So that's how we're doing it. But this is supposed to give you your 6 dB per octave drop. And so if we feed a signal in here and it goes through here and then feeds back, as we vary the frequency of that signal but keep the amplitude the same and go up and down, we should see the action of this. And by adjusting this pot, we should be able to change the amount of influence of that. And that's how this whole equalization adjustment circuit works. And what I'm saying is, by completely shorting this pot, 10K pot out, and allowing the greatest amount of feedback through this, we're still not able to get the high frequencies to be up where they should. Now you might say to yourself, well, why don't we jumper out this 2.7K resistor? Well, that's not really the right way to do this, because you have a greatly degraded high frequency component here. What's going to happen is you're just going to get a whole ton of loud hiss. You will get more frequency, or more of the high frequencies through. It might even get up to the level that you want it, but it's not going to be right. And you're going to hear a lot of hiss. There's no, you can't make chicken salad out of chicken crap. I said it in the last video. If the tape head's bad, this isn't going to work. But we're going to do the little experiment. And like I said, I'm doing this after the fact. Unfortunately, I did not show the influence of this pot. But all it would do is it would just affect more or less of this at the higher frequencies. As you go up and down in frequency. But if this is working, again, we should just see the amplitude vary with frequency. So there you go. Okay, I want to check the frequency response on this thing before we really get into the calibrations, because I just want to see if it's generally working. And I want to do an experiment to observe some things that I've never had a chance to look at in real life. You read about these things, but you never know until you actually observe it. So what you see is I have a couple of little decoupling capacitors tacked into the right and left channel. They're going through a couple of 10K resistors and into my signal generator. And what I want to check is I want to check the equalization circuit and make sure that it's functioning for the cassette deck before we start messing around with anything else. So where is this, you might say? And I will say that if you look on the schematic, here's your playback head. Goes through this little JFET, and then it goes through this little amplifier stage here. And right here where this capacitor is, because these are capacitor coupled, I tacked that cap right here at the base of Q103 and the base of Q104. And we're just going to feed a signal as if it were coming from the head. Now I am going to play a blank tape with nothing on it, just to activate all the circuitry. And the way that the equalization curve should work with cassette tape is at 5 kilohertz, that should be no influence of the equalization circuit. As you go above 5 kilohertz, it should start rolling off the high frequencies. It should start attenuating the frequencies. And as you go below 5 kilohertz, it should start boosting the frequencies. So in a similar manner to the way vinyl works, records, the RIAA curve that you always hear about, you're putting a pre-emphasis and de-emphasis onto the tape. So, and the knee point of that is the 5 kilohertz frequency. So I don't know, if we feed this in there, we should be able to see if we set. So what I'm going to do is I'm going to set the signal level using these signal level meters built in, so that at 0 dB that will be 5 kilohertz. And then without adjusting the amplitude of the signal generator, I'm going to increase and decrease the frequency above and below 5 kilohertz. And what should happen is, as I go above 5 kilohertz, you should see the signal drop. And as I go below 5 kilohertz, you should see the signal increase in amplitude. Anyway, that's what I think will happen. So let me get the signal generator set here and we'll try it out. Okay, I have the signal generator set at about 2 volts RMS, and remember, this is going through the resistor network and those capacitors. So I know it's just an arbitrary number, and I have 5 kilohertz set. I'm going to start the tape playing. Tape is playing now, and There's your signal generator. So you're not looking at what's coming off of the tape. The tape is blank. So if I turn off the signal generator, you can see there's nothing there. If I turn it on, there's our signal. Alright, let's increase it till it gets up to 0 dB, and you can see the channels are not balanced, and there are some adjustments inside there for it. And right there. I think that's about it there, right? Right there. So they're off a tiny bit, and that's just an adjustment that we can do. Alright, now I'm at 5 kilohertz. Let's go to 6 kilohertz, and at 6 kilohertz we should see it drop. So let me see, frequency 6 kilohertz, and you see what happened? It dropped. And if I go to 7 kilohertz, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 kilohertz, and you can see how far it drops. Let's go back up to 5 kilohertz, back down to 5 kilohertz. Now we're going to start going down in frequency. So 4 kilohertz, 3 kilohertz, 2 kilohertz, and you can see it pegged the meter already. And the reason being is when you get down to the lowest audible frequencies, there's almost 20 dB of gain. And of course these meters only read up to plus 8 dB. So very rapidly you'll see you'll just spike the meters here. That's how it's supposed to work. So the equalization circuit is working. Pretty cool. So after doing that little experiment, you can see why it is so imperative that if you're going to do an alignment on a tape deck, you have to have the proper alignment cassettes. These have to be recorded at a very specific level. In other words, the frequency has to be accurate at the exact correct tape speed, and they have to be the correct amplitude on the tape. And they have to be aligned across the track to the standard alignment width across the tape. And if the tape recorder that you make this on deviates in any of those standards, your whole alignment's going to be off. So that's why these tapes are very expensive and hard to make, and there's not a whole lot of folks out there that has the equipment to make these. This is a tape, well, this is an old one. This one's from 1981, so it's still good, but there is a possibility that some of the higher frequencies could be degraded a little bit. That's common with these older tapes. Now, I have an original one, or that I just had made. I shouldn't say original, but there's a company called GenLab, and they're still making reproductions of the different types of test tapes. Different manufacturers use different frequencies and different amplitudes to set up their decks. They use different standards. All of them use those standards so that the deck will perform to the international standards. I know that sounds crazy, but what points they choose to test at and to align at determines what type of tape you're going to need. So this is one of the GL341 cassette that they tell you to use in the service manual for the Pioneers. And it has, I think, 3 different frequencies on it. It has like a 315 hertz, something like a, I don't know, 10 kilohertz or 12, something like that, and then a 14 or something like that. There's like 3, and there's a couple different amplitudes that it has on it. And it's very accurately made. So this tape, you don't want to keep it near any kind of magnets or anything like that. You want to protect it, and you only use it when you're doing these alignments. So I'll usually start with, my older tape, and with more readily available standard tapes, that's the 3 kilohertz and the 3150 hertz, and just for wow and flutter and things like that. Those are cheaper to get and easier to get. And then when it's time to do the final alignment of the equalization and everything, then you use your good tape. So that's where we are. Let me get this stuff out of here now, and we'll start looking into this. I think the next thing we need to do is kind of take a look at this wow and flutter situation. Because as one of the viewers pointed out, the 0.06, 0.07, whatever it was, wow and flutter is over double what it should be. It should be 0.03. And after looking at this a little more carefully, I think, well, I have something I'm going to try. I don't know if this is the problem, but I suspect it might be, at least contributing to it. So you can see I have the tape transport open, and you can do that without taking the whole faceplate off by removing this little cover plate, which sits under here. There's two little screws. If you have the little spanner screwdriver to get them out, it's not that hard, but you can also use a pair of tweezers like I did here. And I'm sorry I have the autofocus turned off, but you can see you can turn it with the tweezers. Anyway, if we zoom in a little bit, I'll show you where I am with this. When you look at, let me adjust the camera here for a minute. I have you kind of zoomed in on this little spring back here. It is connected to the little push plate that connects to this little arm that brings the pinch roller up to the capstan. And it's adjustable, so it's kind of hard to see. Let's see if I can put a flashlight in there and make it a little brighter. But you can see in there, sort of, that this little spring actually can be adjusted. There's little teeth in there, and you can slide the spring back and forth. And it's right now, it is when you move the spring this way on this arm, it increases the tension of the pinch roller. If you move the spring this way, it decreases it. The little glue that was on there, this was set to the maximum tension. Now, that's important because I put a brand new pinch roller on here, and of course it's a Chinese one, so we don't know the quality. But if I refocus this a little bit and show you the pinch roller itself, you can see how it's got these ridges already on it, these marks. This is very soft rubber, and probably because it's inexpensive. And as such, I think the extra tension is causing the rubber to distort a little bit, which is contributing possibly to the wow and flutter. Now this side has a much softer spring on it, and it has a lot lower tension on it, and it's not marking up the pinch roller nearly as much. So what I'm going to try to do is I'm going to try to reach in there and move that spring over one or two clicks to kind of reduce the amount of pressure on the pinch roller and see how it affects the wow and flutter. If it doesn't, even if it does not affect it at all, I'm going to leave it like that, because if I put too much tension on there, it's just going to wear the tire out faster. So the idea is to put enough tension to minimize the wow and flutter, but not so much tension that it causes excessive wear, if that makes sense. So I'm going to try that, and to do that, I'm just going to, instead of taking the whole thing apart, I'm going to try to reach in there with one of these little tools and just kind of move it over. And I don't know how I'm going to be successful with this, and I'll try it on camera, but if I can't do it, then I'll have to move the camera for a minute while I do this. I'm on the spring. Yep, it worked. There's one click. Let's see if I can get one more click out of it. There, right there. And what that does is that really reduces the amount of tension on there. The other thing I notice is that this little plastic cover is kind of sticking in there a little bit. Of course, it never goes down that far. The other thing I'm going to do now is I'm going to clean that pinch roller back off and make sure that it's in good shape. So I'll take that and clean it. I have some new foam swabs, so let me get those. Okay, I'm going to take one of these little foam swabs and I just have some distilled water, and that usually is enough for these new wheels. You don't need the rubber renew stuff. That contains xylene and I don't know what all other kind of, there's 3 or 4 chemicals in those that are pretty intense. And distilled water is usually just enough to clean these off. And these little foam swabs, I did get some new ones because I had run out. And we can use those to clean this off. And then the water will just evaporate. The other thing is sometimes these cap stands get too smooth. I know that sounds kind of ridiculous, but sometimes those, you can improve them a little bit by roughing them up very, very slightly. You know, with some really, really high grit sandpaper, you know, like 2500 or higher, even the 6000 or 8000, and just barely touching it on there while it rotates. It doesn't take much, but I'm not going to do that right now because I don't think we're going to need that. Okay, so we'll wait for that to dry. If we don't get everything off of there, we may have to use a wee little bit of the anhydrous isopropyl. And I know people say don't use alcohol on the rubber because it takes the natural oils out, but the anhydrous isopropyl, the reason I use that is it dries very, very quickly. As fast as you put it on there, it dries. It doesn't have time to soak in to lift the oils and things up. So that you usually don't have any problems with that. And I still see a little bit of streaking on the wheel, but all in all, I think it's okay. So we'll go through it and get the tape set back up. And let's see if this tensioning adjustment and this cleaning did anything for the wow and flutter. Okay, here we are, and you can see we have improved quite a bit. We are on the JIS, and it is 3 kilohertz weighted RMS, 0.1 scale. So that means this up here is 0.1. This is 0.04, 0.03, 0.02. And it's floating around a little bit. You can see it's still a little bit high. It's 0.035. When I first turned it on, it was sitting at 0.025. I think this is because of the regulation of the motor. Remember, if the motor is not regulating properly, that will cause a little bit of wow and flutter as well. But we are very, very close right now to where we want to be. So we're going to have to adjust our motor a little bit, and you can see the drift is ever so slightly off as well. See up here? And again, it's very low, but it is a little bit off, and you can see it kind of moving around a little bit. So you can see how these tiny little adjustments make such an enormous difference. So let's make a couple more adjustments to the springs, and I will also look at that the motor adjustment, that phase adjustment on the oscilloscope once again. We'll go over that, and maybe we'll adjust that using the wow and flutter meter as well. Well, it looks as if we found another problem, and it's pretty obvious. Should have thought of it. If you look right here, this is the potentiometer you adjust when adjusting the phase on the drive board for the capstan motor. And the procedure for it is that you put a jumper between two pins, which jumpers out a little switch on the pitch control. So what am I talking about, huh? If we back up here and we go down just a little bit, let me put on autofocus for a second. So if you look down here, you have this pot, which is a pitch control, and it has a center detent on it. And you see the light turning on and off? When it's in the middle in the detent, there's a switch that kicks in, and it turns on the quartz lock. And when you rotate it to the right or to the left, it comes off of quartz lock, and it becomes a manually adjusted speed. And the way this works is by adjusting this. If I go above, it should speed up. If I go below, it should slow down, and it should be very accurate. What I'm finding is if you adjust this pot up here, the pot is very noisy. So you adjust it, it's all over the place. Now that pot, I believe, also affects the quartz locked circuit. And I'll have to look in the schematic to verify this, but it can also offset that as well. And what I was noticing is when I was turning this to the right, instead of the motor speeding up, it would slow down. And if I turned it to the left, it would slow down. And if I adjusted this pot so that it would, be speeding up to the turning it clockwise and slowing down, turning it counterclockwise, the drift would go insane. It would be way off, and then you just touch the pot and it would just come back in. And let me show you that. We'll play the tape, and I'll just turn this pot a little bit. I'm going to turn this from quartz lock to plus and minus. I'll show you what I'm talking about. So let's go back up here and zoom in on our wow and flutter meter. There we go. Hope you can see it. I have the lights off to get rid of all the glare and so forth. And there, we're auto-focused. I hope that stays in. And if I hit the tape, don't pay attention to the wow and flutter side, because this has to average out. It takes a little bit to adjust. So you can see my drift is pretty close to zero right now. It's a little bit low. If I turn the pot clockwise, which should make it go this way, watch what happens. Okay, now it's working. If I go back to the middle and then I go counterclockwise, just barely touching it, look how much it throws it off by. I'm literally just coming off of the detent, so it's not balanced. So let's adjust this pot a little bit. I'm going to go this way again, and then I'm going to try to adjust the pot, and you see what happens. I just touch it, and I'm now maxed out on the pot, and it's not having any effect. And if I go this way, there's nothing. Now it just took off. See that? And you see what the wow and flutter meter is doing? So obviously there's a big problem. So I'm going to replace that pot with a 10 turn. And we're going to see if that makes any improvement. So looking at the schematic, I've highlighted them. There's two pots on this board. The fine pitch adjustment is a 6.8K. It goes into this chip here. And you can see there's your crystal, your oscillator, and for your quartz lock. And then over here you have the speed adjust, which is the 15K, and that's the one that's given us all the fits right now. And both of these are just variable resistors. In other words, it's not the center tap or the wiper is tied to one end of the pot. So we can use a similar value that's not exact, if that makes sense. Let me turn autofocus back on. So what that means is that I have instead of a 15K, I have a 20K pot that is a 15 turn, so it's very accurate. So that will be more accurate than this. And I'm going to put a 10K 15 turn in place of this 6.8K. And then we're going to fine adjust it, and hopefully that'll clear up that problem. Okay, the pots are replaced, and I replaced the capacitors, and I am pleased to say take a look at that. What do we see here? Yeah, I'm on the 0.1 scale. So that is 0.005% wow and flutter. I think we fixed it. Okay, there's our 10 kilohertz. It looks good, but I don't know how the equalization is going to be when we go down to the 300 hertz or the 330 or whatever it is. We'll check it out. Okay, there's the 333 hertz, and they're slightly different from one another, but on the meters on the front of the unit they look the same, and I think that's because, and he's talking again, I think that was because I have the frequency counter on one channel and it's loading the channel different than the other one. This is going into high impedance. I probably should terminate these outputs a little bit better. But I think it's okay now. The high frequencies are still deteriorated a little bit, but we're talking maybe 3 dB, somewhere between 3 and 5 dB, which is a lot, but not as bad as it was. Let's just put it that way. So if I rewind this a little bit and we go up to our frequency counter, let's look at that. I don't know if you could see it with the glare, but looks like it's okay. You could say it's staying right around 333 hertz. Very close. It's holding it. I'm pretty happy with that. It's fluctuating around about 1 hertz. That's perfect. And those are off a wee little bit, but not huge. And if you look down at the meters, they're actually tracking really well. Oh, he's talking again. You can see they're right on 20, minus 20, where they're supposed to be. So again, I think that discrepancy you're seeing is because of the loading of the outputs. I think we're ready to listen to a tape. Okay, of course the furnace is going to kick on. And I'm just going to use the little SMSL amplifier. It doesn't have tone controls or anything. It's just a little Class D, the bench amp, with my little home-built speakers. And I think you're going to hear a difference from the last time we listened to this. Let's see. Yeah, a lot more highs. Let's get a different song on here.
I got a song that I sing, I can make the rain go anytime I move my finger.
I don't know. It sounds a lot better. And again, I do think the verdict is that the head is a little bit depleted, but I don't think it was as bad as we all thought in the beginning. I do think that maybe if we replaced some of the key audio path capacitors, it might help even a little bit more. And finished doing the alignment, which is still needs to be gone through one more time. But I think this is going to be a very serviceable unit, especially for those like myself who just don't have the really high frequency response in our ears that we used to. So I'm going to wrap this part up and I'm going to get it posted, and in the next part what we will do is we will begin to go through the alignment again, and I may get the HP 3580 spectrum analyzer involved because it has an extremely low noise floor and it can look at very, very low signal levels. So we can look right at the output of that buffer JFET where it comes out of the tape head and look directly at the amplitude of the signals coming out of the tape head with the test tape playing. And that will give us a better indication of where the tape head is. So that'll be on the next video, because this one I'm sure is going to be very long as it is. And but we are making improvements. I feel a lot more confident about this restoration now at this point. So as always, I wish you all peace, joy, happiness, and good health. And we'll be back real soon here with another part, but might be a little delay now that I think of it because of work. I have a lot of things going on, but we'll get on it as soon as we can. Until then, stay well, and we'll see you soon. Bye-bye.